Hello friends, in the last few videos we discussed about the projectile motion and we said the key idea of solving problems related to projectile motion is the superposition. Basically, when you have a projectile motion, this is a two-dimensional motion. So what we do is we decompose this problem into one-dimensional problems. So we separate x-axis motion and y-axis motion and we analyze these two directions motion and we write equation and we solve the problems. Now in this video we'll see how to calculate maximum height, time of flight and range of a projectile when this projectile is thrown on a horizontal plane. So let us consider this is my y-axis and this is my x-axis. And a projectile is thrown with initial speed u at angle alpha. So this is the path of the projectile that it will follow. So this is the projectile path. So at certain point of time it will reach maximum height. So let's say this maximum height is somewhere here. So we have to find what is this maximum height. So maximum height is the height reached by the projectile which is maximum for the duration when it is in the air. Another term we have, that is time of flight. So what is the time for which this projectile remains in the air? So we'll call this maximum height as h, time of flight with t, and the range, that is the distance covered on horizontal plane, that is called range. That is from launching point to the landing point. So on the horizontal plane, what is the distance between launching and landing point? That we will call as range. So in this video we will try to find these three terms and how we can calculate expression for these three things. Once again, to solve this kind of problem, we have to first write what is the velocity in the x direction, what is the velocity in the y direction. So if you decompose this velocity vector, in the x direction you can write velocity is equals to u cos alpha. And in the y direction, this velocity has a component of u sin alpha. Now there is no acceleration in the x direction, so we can say x is equals to 0, and there is acceleration in the y direction, that is acceleration due to gravity, and this is in the downward direction, and I have chosen y direction is the upward direction, so this will be minus g. So now I have this, I want to calculate these things, that is height, time of flight and range of projectile. So let us first focus on calculating height. So we want to calculate what is the maximum height that this projectile will reach. How we will find the maximum height? What is the key idea? The key idea is when this reaches to the maximum height, that is this point, this will have y direction velocity is 0, because if there is a still y velocity, in that case it will go still further. So this means this will not be the maximum height. So this means when you have maximum height, there is no velocity in the y direction. This is the key point, that is Vy is equals to 0. Mathematically this is same as dy by dt is equals to 0. So y is maximum, and y is maximum, this is nothing but maximum height it reached by this projectile. So we'll use this fact that Vy is equals to 0 to calculate the maximum height reached by this projectile. So let us write velocity Vy as a function of time. So we can write, now I can use this expression v is equals to u plus at. If you remember, I can use this expression kinematical equation. Now I can use this in the y direction. So I will write Vy is equals to u by plus a by times t. So what is initial velocity in the bidirection? In this case, initial velocity in the bidirection is u sine alpha. So this is initial velocity plus acceleration. Acceleration in the bidirection is minus g and times t. Now as I said, when I will have maximum height, v by is equals to 0. So this term is equals to 0. So from here I can calculate time, and this is the time, that is u sine alpha divided by z. This is the time then maximum height will be reached. So after this point of time, maximum height will be reached. Now once I know the time, I can use formula s is equals to ut plus half at square to calculate the maximum height. So let us use the formula, that is s is equals to ut plus half at square to calculate the maximum height. Now once again, I will write this equation in the bidirection. So I will write by is equals to u by t plus half a by t square. So let us calculate this by is equals to, what is the initial velocity in the bidirection? That is nothing but u sine alpha. What is the time when I want to calculate by, that is maximum height reached, and this we just calculated. This is u sine alpha divided by z plus half. What is the acceleration? Acceleration is minus z, because this is acting in the downward direction. What is time? This is the same time that we just calculated, u sine alpha by z, and this is raised to the power 2. So from here I can calculate by is nothing but u square sine square alpha divided by z minus half, and this will become u square sine square alpha divided by z. You see, this term and this term is same. Only thing is there is a difference of 1 by 2, coefficient of 1 by 2. So if you subtract this from this, you will get u square sine square alpha divided by 2z. So this is the maximum height reached by the projectile. So I can say maximum height is nothing but u square sine square alpha divided by 2z. You can write same thing, u sine alpha divide a whole square, and this divided by 2z. So u sine alpha is nothing but vertical velocity, initial vertical velocity. So one can also remember this is nothing but u by a square divided by 2z. So this is the maximum height reached by the projectile. Now let us come to time of flight, that is the time for which this projectile is in the air. So we want to calculate time of flight. So what will be the key point when we are calculating time of flight? Can you tell me what will be the key point? This is the projectile and this is the path. So when we want to calculate time of flight, we can use the key idea, that is at one point of time, that is t is equals to 0, this is at origin, that is by coordinate is 0. At again t is equals to t, the by coordinate is again 0. This means there are 2 points of time when y is equals to 0. So what we will do is, we will write expression for y, the displacement in the y direction, and once I write that expression, I can equate that is equals to 0, from where I can get the time. So what is the idea? I will plug y is equals to 0, and from there I will get time. So let us try to do this. So how will you calculate by? If you remember, s is equals to ut plus half at square formula, and I will apply this formula in the y direction. So I will write by is equals to u by t plus half acceleration in the y direction t square. So by is equals to, what is the initial velocity in the y direction? This is nothing but u sine alpha t plus half. What is the acceleration in the y direction? Minus g t square. And now we have to equate this is equals to 0. So I have to equate this with 0. So let's take t common. So I can write the same expression, that is u sine alpha minus gt divided by 2. This is equals to 0. So this gives two value of t. T is equals to 0, and so this is one expression. Another is t is equals to 2u sine alpha divided by z. So there are two root of t, and this is obvious because this expression is quadratic in t. What this means? Y value is 0 at t is equals to 0, and the y value is also 0 at this t, that is 2u sine alpha by z. And this time is nothing but time of flight, that is the total time for which this projectile is in the air. So this time is nothing but time of flight, so we can write time of flight is equals to 2u sine alpha divided by z. Now finally we can also calculate range. So how will you calculate range? So what is the idea? What is the key idea for calculation of range? Once again, the key idea is we can use the fact that there is a velocity in the x direction, and this projectile has been in the air for time capital T. So if I take x direction equation, I will get range. So let us apply this expression s is equals to ut plus half at square and apply this in the x direction. So x direction ux into t, and acceleration is 0. So what is x? X direction initial velocity is equals to u cos alpha. And what time I am interested? I am interested in total time. Then I will get range, the total time for which this projectile was in the air. So u cos alpha times total time, that is time of flight. Now I know expression for time of flight. I can plug this value, that is 2u sine alpha divided by z. From here I can write u square sine alpha cos alpha, and this divided by z multiplied by 2 also. There is a formula in algebra, that is 2 sine alpha cos alpha can also be written as sine 2 alpha. So this is u square sine 2 alpha, and this divided by z. So this is the expression for range. So now we calculated range. So range is equals to u square sine 2 alpha divided by z. So this is the horizontal distance that the projectile will cover in time of flight, that is the total time that was in the air. So we calculated the horizontal range, time of flight, and the maximum vertical height, that is maximum height reached by the projectile. Now we will try to see some special cases for height and range. So what was the expression for maximum height? The maximum height is u square sine square alpha divided by 2z. So this was the expression that we derived. Now if u is fixed, when the maximum height will be reached? So this means I have fixed u, but I am changing alpha. So alpha is changing. What this means? This means I have a velocity that is fixed, but now angle is not fixed. I can throw at this angle, or I can throw at this angle, or I can throw at this angle. So projectile angle by which I am throwing is not fixed, but u is fixed. Then I am asking for what alpha, for what angle this h will be maximum. So h will be maximum only when sine square alpha is maximum. So what this means, I can say h is maximum when sine square alpha is maximum. And when sine square alpha is maximum, you know maximum value of sine alpha is 1, and this can happen only if alpha is equals to 90 degree. This means if you want to a maximum height, you have to throw vertically up, So you have to throw vertically up. So if you have u is given and you want to maximum height attained by the projectile, you have to simply throw in the vertical direction. Now what will happen if alpha is equals to 0 degree? In that case, h is equals to 0 because sine alpha is equals to 0. In that case, no maximum height will be reached. Basically, in that case, what you are doing is you are throwing projectile horizontally. So no maximum height will be reached in that case. Now next question is when range will be maximum. So we have expression for range. Range is nothing but u square sine 2 alpha and this divided by z. Now when this range will be maximum? So if I want my range to be maximum, this means what? This means u is given, u is fixed. So u is fixed. I can only change the angle. This is possible only if sine 2 alpha is maximum. So if I have sine 2 alpha that is maximum, then I will have maximum range. So for maximum range, I can say sine 2 alpha is equals to 1. This is possible because maximum value of sine alpha or sine theta is equals to 1. And this is possible when 2 alpha is equals to 90 degree. This also means alpha is equals to 45 degree. So if you throw an projectile at angle of 45 degree, you will have maximum range. So if you want to maximize the range, so let's say this is the projectile, and if you want to maximize the range, in that case you have to throw this projectile at angle of 45 degree. If you throw any lesser angle, it will not reach, it will not go up to this distance. It will basically fall somewhere here, somewhere here. So if you want to maximize for a given velocity, you have to throw at angle of 45 degree. Another important point about the range. So what is the expression for range? Range is u square sine 2 alpha divided by z. Now in this expression, if I plug 90 minus alpha in place of alpha, what will be the range? Range is equals to u square sine 2 times 90 minus alpha divided by z. So this is nothing but u square sine 180 degree minus 2 alpha divided by z. And if you have some idea of algebra, you can say sine of 180 minus theta is equals to sine theta. So from here I can say this is again same as u square sine 2 alpha divided by z. So this gives me one important result, that is if I throw a projectile either at angle alpha or at angle 90 minus alpha, both will give the same range. For example, if I take alpha is equals to 30 degree, then what will the value of 90 minus alpha? 90 minus alpha will be 60 degree. This means if I throw a projectile either at angle of 30 degree or at angle of 60 degree, in both case range will be same. And this I can show in this diagram. So let's say if I am throwing a projectile at a angle of 30 degree, in this case this is the range. Now the same, if I throw at angle of 60 degree, so this is 60 degree, so this is 30 degree, this is 60 degree. In this case again, this projectile will also have the same range, that is range value for both cases are same. So this is the range in both cases. Mind, in both cases this is not maximum, this is less than maximum. So this is maximum range and this, let's call this as range. So this range is less than maximum range, but both are equal. So if you are throwing a ball at angle of 30 degree or 60 degree, in other words you can say this is same amount of angle from the 45 degree downside, another is upside. So what is the difference between 45 degree and 30 degree? Difference is 15 degree. What is the difference between 60 degree and 45 degree? Again 15 degree. This means if you are throwing a ball, so this is 45 degree angle. So either you throw 15 degree this side or you throw 15 degree that side. In both cases you will have same range. This is not only true for 15 degree, this is true for any angle theta. So from any angle theta, this side from the 45 degree line, and any angle theta this side from the 45 degree line will have same range. This is very important result if you are throwing a ball at the angle of alpha or you are throwing at angle of 90 minus alpha. In both cases you will have the same range. So we derived expression for range, maximum height and time of flight. Remember, you don't have to memorize these formulas. The reason is, in deriving these formulas we have made some assumption. The first assumption is the launching point and the landing point both lies on a horizontal plane. You will see in next lecture that if you have an inclined plane, how do you calculate the time of flight, range and maximum height. So I hope you have enjoyed this video, and if you enjoyed this video, please share with your friends, and I will see you in the next video. Thank you. Bye. Take care.